Okay, in this video, we're going to be talking about nth roots, radicals, and rational exponents. We'll be moving from radicals to rational exponents, like converting between one form and another, and then we're also going to evaluate these expressions. Let's get started. So what is a rational exponent? Well, usually it's an expression that has a fraction in the exponent. Let me show you. So, in general, I'm going to read it. We have the nth root of c. We have the index of n for the radical c, so the nth root of c. We could rewrite that as c raised to the 1 over n power, because what they do not show you is there's actually a 1 right there underneath the radicand. We can also extend this to if the numerator here is not 1. So let's say m and n are both integers. I can have c raised to the m over n power. I could rewrite that as c to the 1 over n. That whole thing raised to the m power. This is the power of a power rule in reverse. And then I could write that using a radical. The nth root of c raised to the m power. And I can go the other way. The nth root of c raised to the m power. And that I can use the power to a power rule to break it apart and write it using a rational exponent on the outside. So it's c to the m, parentheses, raise that whole thing to the 1 over n power, which gives me c to the m over n. And then use these facts to evaluate some expressions. But first, let's actually replace c, m, and n with some numbers. Let's go, what if we do 27 to the 2/3 power? Well, that equals 27 to the 1/3 squared, which equals cube root of 27. Put that out here, squared. Well, that's, what is that? 3 squared. Cube root of 27 is 3. Which is 9. Okay, so this is how it works. This is just basically what's happening. Let's evaluate a couple expressions and see what we got. So, see this one first. I'm going to go down. We get 32 to the 1/5. And then I'm cubing that, power to a power. And then I am going to get the 5th root of 32, and I cube that. 5th root of 32 is actually just 2, and then 2 cubed is 8. All done. Here we have 27 to the negative 2/3. It's going to be 27 to the 1/3, like we did before, raised to the negative 2. And then that's going to be the cube root of 27, and I'm going to put my negative 2 to the power on the outside of the parentheses. Cube root of 27 we saw before was 3. Remember, negative in the exponent means I take the reciprocal, or excuse me, yeah, it's the reciprocal, or this term in the numerator moves down to the denominator, and my final answer is 1/9. 50 to the 3/4, it's going to be 50 to the 1/4. I raise that to the 3rd power, power to a power. This is the 4th root of 50, which is not a very neat number. It's not an integer. Okay. So we could choose to use a calculator or for the entire thing, or we can do the inside part. So the 4th root of 50 is approximately 2.659, and it goes on a bit. And then when I cube that is going to give me about 18.0803. So that's an approximation. We had to round. You can also just punch this number straight into a calculator. Okay, but it's when we have variables, you won't be able to do that. So it's important to understand how we can manipulate the exponent and the index and the radical symbol to be able to do some of these operations. That's it for this video. We'll have one more video we'll be simplifying radical expressions and solving radical and expressions with rational exponents.